this is the classification of matter. So for matter, we can have two types, either pure substances or a mixture. Pure substances can either be elements, so it could be just a pure element, as in the elements that are provided in the periodic table, so zinc, copper, aluminum, what else, iodine. And you can, you can see that the atom there's only one type of atom, and that's the element's atom. So for example, let's say that's copper, right? So it only has copper as an element, as an atom, right? Then a compound is actually two different types of atoms joined together in a set proportion. So they're the same, so there's only two different types of atoms, but you only see one type of compound. So you see the green with the orange, right? Green with the orange, green with the orange. So this would be one type of compound. So there's a difference between having this and then having like one extra, let's say a hydrogen atom there. That would then be a mixture of compounds and elements, because you have these compounds and you have elements. If you had other types of compounds, like let's say here it's green and orange, but let's say you had like purple and orange, then you would have a mixture of compounds. Okay? If you have a mixture, then you either have a homogeneous mixture or a heterogeneous mixture. And a homogeneous mixture would be example of tea, right? So you can't see the separation of tea. Like, it's literally just tea. That's all you see. You see a liquid. And so that means that it's evenly spread out, the atoms. And then for a heterogeneous mixture, you can see the separation. For example, in a fig fruit, you can see the seeds separated from like the orange, actual fruit salad, right? I don't even know. And then, so you could also see the separation in atoms in the chemically as well. Okay, so as another example, let me pull this up closer. So you can see an element would just be the pure element. The compound would be, I think this is sugar. And then a mixture would be a homogeneous mixture like tea, right? We had that in the previous example. And then a heterogeneous mixture, you can see the separation like from, let me pull that closer, like from the top. So I don't really know what that is though, but you can see the separation from the top and the bottom. Okay, let's try some examples. Okay, so the direction says element, compounds, and mixtures. Classify each of the pictures below by placing the correct label in the blanks below. So we have element, compound, mixture of elements, mixture of compounds, and mixture of elements and compounds. Okay, each circle represents an atom, and each different color represents a different kind of atom. If two atoms are touching, then they are bonded together, meaning they are a compound, or in other words, a molecule. Okay, so for the first one, which would we say? Is it an element? No, because an element would actually be number 5, right? So you see the difference. You see just one type of atom, so that would be an element. But this one has actually an element with another type of element, right? So we have the white ones too. So what I would say is that this would be B. This would be a compound because it has two different types of elements joined together in a set proportion. As in, they're the same proportion. They're the same type of compound. Okay, next one, number 2, is this, we can say, let's look at it. So we have two different types of elements. We have a black one and we have a white one. So I'm going to say that this is a mixture of elements. So I'm going to say that's C. Number 3, okay, so we have, this would be like an element, but it's not just a single element. They're two elements, but they're the same element combined together. So it's not a compound, okay? So you want to make sure that you know that this is not a compound, because a compound is two different types of elements combined together. A compound is two different types of atoms combined together. You can't even see it. In a set proportion. And these actually are not too different. They're the same. So they're white and on white. So it's not a compound, but you do see that there's a compound here. So you have black and white, right? So I'm going to say that this is a mixture of elements and compounds, okay? So that's going to be E. So that's a mixture of elements and compounds. Okay, moving on to number 4. What are we going to say for this one? So we see 2 different types of compounds, actually. So we see this one, and then we also see this type of compound. Okay, so this is not a compound in itself, because a compound is just 2 different types of atoms joined together in a set proportion. So individually they are compounds, but together they're not. They're actually a mixture. They're a mixture of compounds, right? So that's going to be D. Okay. For number 5, we already said that's A, an element, because they're the same type of element. They're the same type of atom. Okay, number 6, what can we say? I'm going to say that this is just a compound, right? B, because they're the same type of compound. They're all the same type of compound. And what is a compound again? It's 2 different types of atoms combining together in a set proportion. What do I mean by set proportion? I mean the same way. So instead of, we can look at the, let's see, so we have white to black. So we can say, okay, there's 2 to 4 blacks. So that's what I mean by set proportion. It's the same proportion. If there was, let's say, 3 whites and 5 blacks, then this wouldn't be a compound. This would actually be a mixture of compounds, because they would be different types of compounds. Okay, but no, right now it's just a compound because they're all the same. They all have the same proportion. Okay, moving on to number 7, we're going to say that this is an element. Now, why? Even though there's like, they look together, again, remember that this is not a compound, it's actually just an element, because a compound, we want to keep repeating the same definition so we memorize it, is 2 different types of atoms joined together in a set proportion. Okay, and this is not 2 different types of atoms, it's the same element. Okay, so it's A, it's an element. Number, what is that? Number 8. Number 8. So we see 2 different types of, 3. Okay. So we see one element here, we see another element here, and then we see a compound here. So what I'm going to say that this is actually a mixture of elements and compounds. So that's going to be E. A mixture of elements and compounds, because we have 2 elements and we have 1 compound, so it's a mixture of elements and compounds. Moving on to number 9, so we have one element here, we have another element here, so I'm going to say that this is a mixture of elements, so that's C. Okay, mixture of elements, because we only have elements here, but they're different. Okay, number 10, let's see, we have one element here, we have a compound there, and they all look to be about the same, right? 2 to 1, so white 2 and then 1 black. And so because of that, I'm going to say that it is also a mixture of elements and compounds, okay? Because we have 1 element, 1 compound. Okay, moving on to number 11. So here I see, let's see. They're all the same type of compound, right? So we have the compound and they're all the same type. So we're going to say that that is B, a compound. Number 12, we have, let's see, we have 1 compound. So we have 2 white, 1 black, but here we have 2 black, 1 white. And then let me see, I'm pretty sure that's the only possible. So we have 2 different types of compounds, and because of that, that's going to end up being D, a mixture of compounds. Okay. For number 13, okay, we have 1 compound, so we have 2 black. So we have 2 black to 4 white. So black to white. And then here we have 4 black, actually, 2 white. Do we have anything else? 4 black, 2 white. So we have 2 different types of compounds. Okay, so these are 2 different types of compounds. So because of that, we're also going to say that this is a mixture of compounds, so D. And then number 14, so we have, this is 1 compound. Let's see, this is another compound. This is another compound. So we have here from, let's see, we have 2, 2, 4, so black and white. That's one compound. And then we have 4 to 2, so 4 black to 2 white. And then here is like just different. We have 2 to 1. That's 1. Oh, and then we have another one right here. We have 1 to 2. So we have 4 different types of compounds, yet it is still a mixture of compounds, so that's going to be D. And finally, the last one, we have 1 compound here, we have 1 compound there, and I think those are just 2 different types of compounds, yet it's still going to be a mixture of compounds, so that is D. So these are our answers. Hope that helps, and that's it.